All right, the next thing that we discussed was first this summation notation, how to read this symbolism here and connect it to the operation of addition. And then we saw some uses of it, namely through this idea of the mean and standard deviation. At least one of these that most of us have probably seen in one shape or form at some point in time. So what this means is add everything up and divide by how many, or multiply by 1 over how many things are in that list. So we may have a list like X, 3, 5, 7, 9, 11 or something. And if we want to find the mean of that, we can use NumPy and the mean function, and it will tell us. So the mean of this list is 7. The standard deviation, we're going to add up how different every term is from that mean squared, find the average of those, and take the square root. Remember that without the square root, we call that variance. The square root of it is the standard deviation. So we could also say the standard deviation of that list is 2.8. Now, for the moment, we're primarily interested in means and standard deviations of distributions of outcomes. So if we look at, again, at a binomial distribution with n of 20 and probability of 0.5, so 20 and 0.5, we can look at the mean of that easily. Just say b.mean, and we get the mean of this. So that seems to make sense. If we have a 50-50 chance and we do something 20 times, then half of the time is what we should expect in terms of successes. All right, and if we look at a plot of this, then we see that the mean at 10 is the center of this distribution. It would be perfectly balanced at 10. Okay, let's look at a little larger example where we have 50 outcomes and 30% chance of success. So the mean of this now is 15 because success is less likely. So we're to the left of 25, right? And the standard deviation is 3.24. So again, what do these mean? Well, let's look at a picture here. And our mean of 15, you know, that is where this thing looks like it's centered. The standard deviation of 3.24 is on average how far away from the mean each value was. So it describes kind of how spread out this is. And just for one other example, let's create another similar distribution here. And this time we'll have 20 trials with the same number of successes. Okay, so you see that the mean is lower and the standard deviation is lower as well. So it's going to be a curve. What that should tell us is that if we plot this, it's going to be a curve that doesn't have as much kind of spread in it. And let's try and throw that on the same. Okay, and this, so we do see that this curve is centered lower. It's had a lower mean, and it's much narrower than our blue curve. We can tell that from the comparing the standard deviations. Now these are all on both of these curves just have discrete values on the x-axis. So our last example will be a distribution where we look at x values that have continuous, can be continuous values.